Hello. A relationship between two variables, say x and y, if it is given in this form, y equal f of x, for example, this quadratic equation, y equal to x squared plus 5x plus 11, is said to be in Cartesian form. However, it may sometimes be convenient to express the relationship between x and y through the use of a third variable called a parameter. For example, let's look at this. X is equal to t squared, y equal t minus 1. So this represents some curve with pairs of coordinates of x and y. So for example, when t equals 3, x equals 3 squared, which is 9, and y equals 3 minus 1, which is 2. So the point 9, 2 lies on the curve. Now to find the Cartesian form of the equation of this curve, the parameter is to be eliminated. So if I use the second equation and make t the subject, t is therefore equal to y plus 1. And then I'm going to substitute that result into the expression for x. So x is equal to y plus 1 squared, and expanding, I get that x equal y squared plus 2y plus 1. And this is actually an equation of a parabola. So I want you to try these 5 examples yourself. So after copying down the questions, please pause the video and do them, and then resume the video to see the solutions. So here's our given equations, parametric equations. I could use either one to make t the subject and then to substitute. I'm going to use 1. That seems to be the simpler expression. So I get t is equal to x plus 2. I'm just rearranging this equation to make t the subject. I now substitute that result into for y. So y is equal to 3, x plus 2 plus 4. Expand the brackets and simplify. Y equals 3x plus 10. And this is obviously the equation of a straight line with gradient 3 and y-intercept 10. In our second example, I have my two parametric equations. I'll choose the linear one, which is equation 2, to make t the subject. It's always the linear equation is always easier to rearrange. So t is equal to 1 minus y. And then I just substitute for t squared into the expression for x. And there is my Cartesian equation. In example 3, I'm using equation 1. Make t the subject, t equals 1 on x, substitute it into the second equation, y equals 1 on x plus 1, and then multiplying the equation by x, I get xy equal 1 plus x. Therefore, xy minus x is equal to 1, or I can factorize this and say x bracket y minus 1 is equal to 1. Either expression will suffice. Right, in examples 4 and 5, you note that they include trigonometric functions. For this part of the early part of the course, we are going to make use of this identity, which you should remember from your AddMath classes. Sine squared t plus cos squared t is equal to 1 for all values of t. So whenever we see these trig functions, we have to use identities that we would have learned, or we will learn in trig. So I have x equals sine squared t, that's given. If I square the y, I get cos squared t. And adding the two, x plus y squared is equal to sine squared t plus cos squared t. But sine squared t plus cos squared t is equal to 1. So that x plus y squared equal 1, or x equal 1 minus y squared. And this is the Cartesian form for this curve. Right, in this example, we are also going to use this relationship sine squared t plus cos squared t equals to 4. So these type of questions, they take a little forward planning. So if I square the x, I get 9 cos squared t. If I square y, I get 4 sine squared t. And I want to get some expression with cos squared and sine squared and the same coefficients before it. So if I take 9/4 of y squared, here I have it, it comes out to 9 sine squared t. And so if I add x squared plus 9 on 4y squared, as you can see here, that comes out to 9. There's my expression. And I could either leave that as my Cartesian form, but I multiply everything by 4, so I get 4x squared plus 9y squared equal to 36. And then I divide everything by 36, and I get x squared on 9 plus y squared on 4 equal to 1. And as we will see in future work, this is actually the equation of an ellipse. So let's look at some exam type questions. Show that the Cartesian equation of the curve that has parametric equations x equal to t squared plus t and y equal to 2t minus 4 is 4x equal to y squared plus 10y plus 24. So I take the equation for y and I make t the subject. So here we have it, t equals y plus 4 on 2. I substitute that result into the expression for x. So x equals y plus 4 on 2 all squared plus y plus 4 on 2. I expand here, y squared plus 8y plus 16 on 4, don't forget to multiply the bottom as well, is equal to y plus 4 on 2. Multiply the expression by 4, so I get rid of the fractions, and then I just remove the brackets and simplify and get the result that is required. I want you to try this one yourselves before I do it. So pause the video and try it yourselves and then resume to see the solution. Right, in this one, you might have tried to make t the subject, but there really wasn't any need because I see I have t squared and t to the 4th. So t to the 4th is just the square of t squared. So using the expression for x, I get this relationship for t squared. I know I'm going to substitute this for t squared into the expression for y. Now y has t to the 4th, so it's x minus 3 on 2 all squared. So 3 times x minus 3 on 2 all squared plus 2. Expand the brackets. I get x squared minus 6x plus 9 on 4. And then I multiply by 3. So I get 3/4 x squared minus 3 times 6, 18 on 4x, plus 3 9s, 27 on 4, plus 2. And then 27 on 4 plus 2 is the same thing as 35 on 4. And therefore, there is our Cartesian equation. Y equal 3x squared on 4 minus 9 on 2x plus 35 on 4. Here's another exam question. Parametric equations of a curve S are given by x equal 1 over 1 plus t and y equal 1 over 1 minus t squared. And we are required to determine the Cartesian equation of the curve. Well, I've put down here is what x is, here's what y is given. I notice that 1 minus t squared can be factorized using different subsquares. So 1 over 1 minus t times 1 over 1 plus t. But 1 over 1 plus t is x. So we need to find what is 1 over 1 minus t. Over here, I make t the subject, and I express it as a fraction. And I have 1 minus t, and here it works out to this, 2x minus 1 over x. And then, so 1 minus t, let's change that. This is 1 over 1 minus t is x over 2x minus 1. So therefore I substitute that into this expression for y. So I get y equal x over 2x minus 1 times x, which is x squared over 2x minus 1. And then I just cross multiply and get my required Cartesian equation. I suppose any one of these three equations would have sufficed for an answer, since we weren't given a specific result to get. So here's our final question for this session. So I'm given that parametric equations are x equals sine squared and y equal 2 tan theta. So let's start. We're going to put down our x squared is equal to sine squared theta and y is equal to 2 tan theta. Well, if you cast your mind back to your Add Math class, you would note that tan theta is equal to sine theta over cos theta. Therefore, y equal 2 sine theta over cos theta. And as usual, I want to utilize the identity sine squared plus cos squared equal to 1. So I'm going to square this. Y squared is equal to 4 sine squared theta over cos squared theta. So I know that's x squared, x is sine squared theta. So y squared is going to be 4x over cos squared theta. But if sine squared theta plus cos squared theta is equal to 1, cos squared theta is equal to 1 minus sine squared theta. So our expression becomes y squared is equal to 4x over 1 minus sine squared theta. but sine squared is x. So we get 4x over 1 minus x.